Guys, hello, welcome to another episode of Build Tensorflow. And today we're not going to do any coding. I'm actually going to reset this project to a state that I've been working on right now. I've just organized everything into separate folders, and I've written a little bit of code to incorporate this matrix class that we built into the tensor class. Anyway, this should be deleted, and this should also be deleted. Anyway, so as you can see on the, so let me just yeah, as you can see, the project, the directory structure is like this right now. And let me see, VS Code is not to be status. Yeah, fine. All right. Anyway, yeah. So what I've done here is basically I have this main.cpp, and you have your old sigmoid test and your new sigmoid test. Then you have the main function, which can be anything. So and this main function, this is our entry point to the our deep learning framework is through the build TensorFlow header file. So if we go inside this, there are just two includes. There is a tensor.h from the folder types, and operations implementation.h by the in the operations folder. So let me explain to you the directory structure. So the utils has a common.h, all the utilities that the everything in the project will need, so that can come inside the util. So as an example, common.h hosts all the common header files like iostream, vector, assert, memory. This is needed pretty much everywhere, right? So I made a separate header file. And matrix.h has some matrix utilities like transpose. I built a transpose function which basically does the equivalent of what a numpy just add this to the comments. And what this does is reshapes matrix by taking in a vector that orders the shapes around. So for a 2D matrix, you can send in transpose your tensor and then maybe 1,0. So this will take the 0th dimension and put it in the first dimension, and take the first dimension and put it in the 0th dimension. So that's just an example of transpose. We'll come to why we need transpose later, but for now just think of it like a utils for a matrix, right? And then there's another folder called types. So what types does is it defines all the data types we'll use in our project. So we have just two. We have our tensor and we have a matrix, right, that we built in the last episode. So the tensor, as you can see, I've put in a lot of commands to guide the a new user to what this project is. So I think I've done an okay job, but I need you guys to read this and tell me if something is unclear or not. So as you can see, I have incorporated the matrix class into the into our value, and similarly that for the grad. There's actually one to do for this. We have to initialize it to 0 and keep it as the same shape as well. So that's one function that we have yet to do. Also in our backup is actually wrong right now, because what this assumes is that one tensor is a tensor will only participate in one operation. It can't participate in multiple operations. It can't add with another tensor and multiply with another tensor. So the value of gradient will be set to according to what uh, according to what came last in the depth first search backward operation. So this should actually be something like plus equal to grad. Anyway, if you think about this in the case of matrix multiplication, and you do the math yourselves and go through the backward pass, you'll figure out that our tensors are involved in multiple adds and multiplications operations. So we need this plus for that as well, and for future reference. So this is a little wrong. Fix grad. We'll fix all of this. This is as I said, a non-coding episode. I'm just giving you an update of the project, and then we'll carry on from this state, because it would be a huge pain to debug small things, and I think the listener is aware of what's been happening and what we're trying to do. So one cool homework project for you guys could be like incorporating the matrix class inside our tensor class, which is what I did. So that would mean overloading the matrix class with exponents, powers. We already did overload the matrix class with the plus with the addition, subtraction, addition, multiplication and division headers, and also the dot product, which is the main thing. But there are a few remaining, like exponent that we need in the sigmoid operation, and power to square, and um, 3 so next, the tensor class, we overload the multiplication operation and addition, element wise division, and then there's one more thing that we need from the tensor class is like division with a scalar, which is another thing that is that isn't required to be done in the tensor class, but you'll have to do that in the matrix class. So anyway, let's head on to the matrix and see if there are any updates. Tensorflow, CPP, just close all this. Alright, so let's head on to the matrix class. So this file defines the matrix class. Matrix supports creation of n-dimensional arrays. It supports various arithmetic and matrix operations. Yeah, pretty straightforward. I think it's pretty nice that we have an n-dimensional array data structure right now, so it will make life so much easier when we're bringing computation on the GPU, which I promise it will be next episode. I feel I've been saying that a lot, but there's a lot that goes into making something like this, which I did not realize. So this is pretty much the same thing that we did in the last episode. One extra thing would be extra overloads, I am betting. So this would be so we have overloaded the addition, multiplication, division, and so this is new. This is something that you guys can do yourselves, or you know what, I think we're at a state where I can post the GitHub the link of the GitHub repository in which I'm building everything. It is public, and I'll just post it. And this is not this code, you won't find this code in the main master branch. It will be in the dot product backprop branch, but you can watch the repository, and I'll merge it soon enough. Actually, don't look at the master branch for reference, look at the develop branch for reference. So develop branch will have everything that we're developing, and once we've actually implemented an MLP, we'll release it, an official release on GitHub, and then we can push it to the master. So anyway, we have built your power operation, and then we have built an exponential operation. Pretty good, you don't need to assert anything here. Dot product between two matrices is good. This is the same thing that we did, and we overload division with a scalar also. So this is, you divide with the scalar. This is, you need this in in the sigmoid operation and the backdrop. Anyway, so you'll see that we've even overloaded our vectors. So where is that overload file? So that is simply overloads. Anything that we're overloading, if it's not in a type, we'll put it in overloads.h. So this is just simple vector overloads. Tensor multiplication, addition, division by scalar, power operation, exponent operation is equals, like checking if matrices, two vectors are equal. That comes in handy sometimes. I don't know why it come in handy. I guess, I don't know, but yeah, I think I needed it sometimes. So anyway, so you already know what overloads does. Overloads has all the vector overloads, and types has all the data types of the project. Should we call it build TensorFlow? I'm unsure of the name, so if you guys have some cool names in mind, just comment below, and please subscribe and like the video if you can. Even if you don't, it doesn't really matter. So tests, we have tests here. Okay, so this is something new, is that I'm writing unit tests for every functionality that we built. So right now I'm at a stage where the matrix class is unit tested. So as you can see, I've tested shape creation, shape validation, and I'm using Google Test for this. Google Test is a really great C++ testing library made by Google, and the cool thing about this is, I don't need to write any test code. It's like, if anyone has used JUnit in Java, they'll be pretty familiar with how to do testing. And it's the same thing. You assert if something is equal, or in this case you assert if the program is asserting something. So I've checked for matrix addition, dot product, and then I'm checking if matrices are equal. Oh, I could have used, actually I could have used is matrix equal. Oh, I could have done this here. Anyway, you could have overloaded this, but so I'm checking if multiplication yields the right result. As you can see, this should be the result, and it should. And if you want to see how this runs, make test is the flavor I have built in the make file, and that's how it looks. It just runs all okay, all 8 tests passed. This is a good thing. And then the good thing about tests is, when this is a semi-mature project, then we can run it through the continuous integration, continuous development protocol, that you can get Travis.cl, or Circle CI, or even Jenkins to run on every pull request that you do on the main GitHub repo, and it just validates that everything that should be working is working. I don't think of tests as it's testing the whole application so that it works flawlessly. I think of tests as just a safety mechanism of, when you're coding something new, you want to make sure that the old stuff still works, or the stuff that you care about still works. So it's just so I can test, or I can try out new features with less worry on my mind that I'm doing something wrong, because the test will be there to back me up. So that's how I think about tests. And if when you're testing, test the functionality. Don't test trivial things like if a function is called or not. That doesn't do anything good. You just test what the expected value should be. So in this case, in matrices, it's easy to write tests, because you have a defined input and you have a defined output, and you can just verify if both of them are equal. Anyway, a lot of time being wasted on this. So you can look into this code. This is this macro or function that the Google Test guys have built. You just run all tests, and maybe I'll do a video on testing. Or maybe we'll test the backward propagation of tensors. That'll be a good lesson. Overloads we've already covered. Operations, okay, operation has gone through a major refactor. As you can see, now we have add operations implementation.h and add operation.h. So basically the forward and the backward prop implementations are in another file, and add operation is in another file. so this makes it a little bit cleaner, more welcoming, and the main operation class, which every operation overloads from, is right here. And I've shifted these tensors here, and I've removed any uh, I removed the definition of T1 and T2 here, because during debugging it was getting to be a real pain, because if you remember, we had to do operation and then T1 T2 to actually see if this was, if our backward prop was working well, because when you fire on the debugger in the tensor class, everything is just an operation, and it's not a multiply operation or an add operation. So when I debug this, the T1 and T2 used to come as having no value, because of course they did not. It was the multiply operation or the add operation which had the value. But on removing the T1 and T2 from here, when you set it here, this goes back to our operation and then sets these instead of one layer ahead. So that was one thing, pretty cool. So anyway, this is fairly straightforward. It's the same thing, just a refactored, so that it's easier to code in. And then you have your GPU. In this, it's actually a work in progress right now. I'm actually coding this part out, and so the next lesson would be getting the matrix multiplication onto the GPU. Right now it's on the CPU. We have a build folder which hosts our build files, and if you want to look into the makefile has a bunch of flavors. It has GPU test to test the GPU version of this framework, and this would be normal test. This would be debugging it, so there's just an extra dash G call. That's the only difference. It tests only and run the tests, test.cpp, and this is the main, just the same thing. It just runs main and everything to do with it, and that's about it. That's the video, guys, and I'm going to share the link of the GitHub repository below, and hopefully you guys will find it interesting. And I'm glad I kept this episode short. Anyway, see you next time, guys. Thank you so much. Bye bye.